Hello, welcome. So in this lecture, I'm going to review Milestone 2 and Milestone 3 to help you with Milestone 4 because it definitely builds on this. So in Milestone 2, we were asked to create abstract data types for the classes that are involved in the Uno game. So I did this on the whiteboard in class. Some people missed it, so we'll review it here. Milestone 2. So the way I laid this out, I had a card class, a deck class, a hand class, and what I did not model in class was a game class. So I added it here. So these in the abstract data type is the operations of the class with no detail about the internal operations. So there's no formal way that I could find that abstract data types are written. So I just laid out card, which would have these methods here, deck, which has these methods here, and hand, which has these methods here, and then the game, which has one method, a play method. Now, when we move to Milestone 3, you were asked to write the UML for that, which is formally declared. That is a formal modeling language, unlike the abstract data type. But essentially, it moved directly into this from a card class, a deck class, and a hand class. Not everybody, in fact, only one person did all of these, managed to get all of these things into the UML they defined. That's what it should have happened for everyone. So take a look at this and make a note of it, because this is how you're going to write your code. The idea is that these classes mind their own business. That's another way of saying encapsulation. So the card class encapsulates the behavior of the card, the deck class encapsulates the behavior of a deck, and the hand class encapsulates the behavior of the hand. So if you find yourself writing the play method and you start writing like deck shuffle inside the play method, then something's gone wrong in your thinking. You need to move that logic into the deck logic here. Okay, so the next time we'll look at the code itself for Milestone 3. So this is Milestone 3. We're going to show the enumeration first. So what an enumeration does, an enumeration in Java is actually pretty complicated. It represents a class itself and it has other capabilities. But for our purposes, we can think of it as a very simple thing. It's a replacement for using an integer for a status variable. So for example, if we represented card suit as integer, an integer has 4 billion values. So what are the possible values? It's not really clear in the code. So what an enum does is it says, this is a symbolic constant. It says this has an internal value of 0, 1, 2, 3, and 4. So they're integers underneath, but they're defined integers. They have a certain range, and if you define a card suit variable, it can only obtain those values. So it defines exactly what's involved in that particular variable. So look at the card values as well. This is a standard deck of cards that we'll start with. I'll modify this to be the Uno deck in the next segment. But we have Joker, 2, 3, 4 through Ace, and those, and again, has the same. It's using an enumeration, so it has the same advantages of using an enumeration for card suit. That is, we've defined exactly what the values of our integers are that we're going to use with these symbolic constants. And so our code is more self-documenting, so you can use a card value of 2, 3, 4 through Ace instead of having 0, 1, 2, 3, 4, 5, and with comments that say what they mean. It also defines, so self-documenting code, and it also defines a set of values from the 4 billion possibilities of an integer down to the handful of values that are actually possible in the code. So enumerations are very valuable in general for developing reliable and self-documenting code. So the class that uses the enum most directly is card, so we'll look at that directly. We have a constructor here. Remember how to recognize and write a constructor. A constructor has the same name as the name of the class. A constructor never has a return value, so it doesn't even have void there because it's not possible. This constructor has two parameters, the suit and the value, and it sets then the value of the suit and the value in the particular card, which are declared here. So those are private. We have encapsulation. So the code outside of this class, outside of the card class, cannot affect these properties. In fact, we have just getters here. So once the card is constructed here, the values, since we don't have setters for the outside code to use, the outside code can't modify the values of the card. We have a toString method here that will allow us to print the value of the card. So if you ever see just the name of the class plus a number, that means you need to write a toString for that class. You're falling back on objects toString in that case. So you need to use to write a toString method to convert the value of the object to a string. So I used Eclipse's toString generator method in source. I've showed that several times in class. I won't show it again here. The only thing I modified was I put a new line here at the end of this, so it would go, so when it printed out, it would go vertical rather than horizontal. The next class to take a look at is the deck class, because deck is made up of cards. So we, in our private method here, we have a deck. It's not initialized, so that deck would be null. So a logical thing for the constructor to do is actually create that empty array list structure for cards to be populated. Remember, the job of the constructor is to set up the object for first use, and a logical thing for it to do is to set up the empty array list that will be represented by the deck. The next thing we need to do is populate the deck, and we have a method to do that, and we have these for loops. Now, what's important to note here, when you have a for loop like this, it's going to be very uniform. So it goes through all the possible values, joker through ace, then all the suits, none through spade, so none is going to be assigned to joker. And we avoid in this loop with this if statement allowing the for loop to populate jokers and suits, because that's the one card that's not uniform. So these for loops are only useful for this standard card deck because the standard card deck itself is very uniform. So the for loops are a good representation of that, or a good application of for loops, because the deck is very uniform. The Uno deck has special values in special cases. It is not as uniform as the standard card deck. So when we get to that, we're going to have more logic. When I developed the joker idea, that was the special case for our case. So jokers don't have suits, so none. And jokers, there's only two jokers in the deck rather than four. So those are the two special cases that I stop adding here in order to add manually here. So this of course will create a non-shuffled deck. It's like a brand new deck of cards. They're in order as well, and you need to shuffle them for the first game for a new deck of cards. So this is a brand new deck of cards, and then we have shuffle to randomize the deck. And collections.shuffle is a helper method that already exists in Java, so we take advantage of that to randomize the deck. The deal method also takes advantage of an existing method that exists in ArrayList, that is remove. This removes at an index, and it has the nice characteristic of returning the object that was removed. So from the top of the deck, we remove a card, and so that card is gone from the deck, and this itself returns the value of this. So we use the size of the deck, and remember we start indexing at 0, so we have to subtract 1 from that, and deal card will both then remove the card that's dealt from the deck and return the value of the card itself. We also need a toString method. because as toString is called, let's say on the deck, it needs a toString method, and then that toString method will drill down into cards toString method, so it will show the values of the individual cards and the deck itself. If either one of those objects don't have a toString method, then you're just going to simply get the name of the class plus the memory location of the object. So everything that's involved from the upper level class down to the inside needs a toString method in order to show it on the screen. The next object we'll look at is the hand class. So the hand class has an array list of cards, and in this case, both to illustrate it and also because it makes sense to me, the hand is a private method, or private data member, and I initialize it to be an empty array list here on line 27. There's no constructor necessary because that's done in one step here. But we have a draw card method that adds a hand to the card deck. And then it gets score. I was thinking about a game when I wrote this, so we'll ignore this because Milestone 3 didn't involve any kind of game at all. So back to the abstract data type, you've seen that we've shown card, we've shown deck, and we've shown hand. Now Milestone 3 didn't involve all these methods, so I've just implemented the methods that we needed for Milestone 3. But as you develop the actual game, you'll have to write code for these methods. And once again, if you find yourself in the play method and you're writing shuffle and shuffle logic or card value logic in the game itself, you need to rethink what you're doing and encapsulate those methods inside the classes as shown here. So now we're ready to show the play method itself. So game has a single method called play, and you can think of the play as essentially a manager. So it's going to use the capabilities of the classes card, deck, and and hand to actually manipulate the methods that are available in there to manipulate and actually play the game according to the UNO rules. So it's a manager. So it establishes a deck. It's passed parameters here. That wasn't required here. Passes the number of hands, or the number of players, the number of cards that they're dealt, and then the value they had. In other words, I implemented this as a game, but we're going to ignore that feature because it's not important for Milestone 3. We establish a deck, and we print the deck. That should come out as an empty list. We haven't populated it yet with cards. So we populate it, and this will be printed out in order, and then we shuffle it, and we print it again. So 3 print methods for deck, an empty deck, an in-order deck, and now finally a shuffled deck. We establish the number of hands we are told to establish by this parameter here. So we have an array list of hands. Again, this is an object. This is a class we've written now, so we can make an array list of it, however many we're asked to create, and then we deal card, and then we add empty hands to that structure. So the hands now are, we have 4 hands. If hand count is 4, we have 4 hands that are empty. So the next thing to do is to deal the cards. So we use deck.dealCard, which, remember, removes a card from the deck and returns the value of the card, and that's immediately handed to the draw card method, which adds it to the hand. Now at the end of this loop, we should have 4 hands with card count, which I established at 7. We'll look at that in a moment. 7 hands in 4 hands. 7 cards in 4 hands. And then we print out the hands, and that's essentially the end of Milestone 3. We'll look at the driver method, the test driver here. And main is very simple. And that models what should happen in the real world. Main should be very simple. It kicks off the start of your program. So here we kick off the start of a program by establishing new game. Game has one method, play, which does everything else. We establish 4 hands, 7 cards, and I wanted to count the queen value again. We don't have to worry about that for Milestone 3. So when we run this code, we see the empty deck. We see the deck populated first with in cards in order, so all the twos, all the threes, on through the aces, very uniform again. Diamond, club, heart, spade, those four loops that we used, very uniform, unlike the Uno deck. And then the special cases for us, suit none, the two jokers that we added at the end. Of course, this is in order. This is after calling shuffle, which now you can see that the cards are randomized inside the deck. And then the individual hands that we've dealt out, 4 hands with 7 cards in each hand. And then I actually had a game here. It's called Queen's Count. So the person that had the most queens would win the game. Again, not important for Milestone 3. Next, I'll modify this deck to be an Uno deck. So I found this website here, rulesoftheinternet.com, uno-rules.html, which lays out the types of cards that are in the Uno game. So that's what I based my population of the Uno deck on. I didn't find the way that the website documented the Uno deck to be that convenient for actually writing code, so I turned it into this worksheet here. The possible colors, red, blue, yellow, and green, 4 colors. And then 0 has one of those, so there's four zeros. And then, but 1 through 9, again, not uniform, has 2 of each of these. And then the active cards, this is what the website called active cards, 4 skip cards, 4 colors of skip cards, 2 sets of each of those, and all of those here. And then what they call black active, I think, this is a UK site, so I think they may call those cards black. When in the US we consider those having no color. At least that's what I think. I've never played Uno. And there's 4 of each of those, and I made sure that these numbers add up to 108 that we need in the deck. So the next I'll show the enumeration, how I changed the enumerations, and how I changed the deck populate methods. But those are the only 2 things I need to change. I need to change my enumerations, and I need to change the way the deck is populated. All right, I've modified my code to be an Uno deck. So the suit, I kept the name the same, the suit of the card. Let me reset my perspective here. So the suit is now color. The website that I found that I documented earlier used black to be what I think most people say to be no color. That's the wild cards. So I kept with the website documented it as black, then red, blue, yellow, and green for card suit. So I didn't change the name of card suit to color. That's possible, but I think that it's an analogous to in the Uno game, the color is analogous to a suit. Then the card values, 0 through wild plus 4, so they're all taking account of them. And then the next thing to change is how to populate the deck, and that's over here. Now, as we've discussed, the Uno deck is not as uniform as the standard playing cards deck, so I accommodated that code essentially in a brute force way, populating these cards one by one. There's 108 adds here to the deck to populate 108 adds. Now, whenever you have duplicated code like this, there's possibilities for loops here. But I wanted to show it in a really straightforward way, where we have zeros, as documented on the website. There's 1 set of those. There's 2 sets of the rest of the value cards through 9. And then what they call the active cards, the skip cards, the take 2, and the reverse. There's 2 sets of each of those colors. And then the black active cards, the ones that are assigned black here, the 2 wild cards, I've assigned here. I made one other change to the 2-string method. I added a count here, deck size, to print out so that when the deck is printed, it'll print the 108 cards there as a error checking mechanism. So again, really brute force on populating the deck. I changed the play because Uno Uno decks, Uno game always has 7 cards in the hand, so that's not a choice anymore. I hard coded that to be 7. I removed the little bit of game logic that I had down in here, and the only thing I'm passing in here is the number of hands that I have, so all of that's the same. So run this, and we see the initial deck of empty, then the initial unshuffled deck. You can read through this and make sure there's no errors here. I have 108, and so that's somewhat of an error checking mechanism. Then I have my shuffled decks, and then I have my individual hands here, populated with random values that got pulled from the deck. And that's it. Now we're ready to play Uno, and that's essentially Milestone 3. I made one other change here in the card class. So I added a setter here for the suit. So when you play it, the idea here would be when you play a wild card, the color can be assigned to the wild card as they're played. So the player essentially says, I have a wild card, I'm going to play it, and assign it a color other than black at that time. So then your card matching logic is simplified because the wild card, say, is assigned green by the player. It now has a color. And that could, when you write your match method, you can say, okay, it matches due to because it now has a color. That's it. So good luck on Milestone 4. Get this typed in and working as soon as possible, and start working on Milestone 4 because it's very important to get the milestones done for your grade. Thank you, and I'll see you in the next lecture.